Chapter 2.1 Transformation of Quadratic Function. Different types of transformation using left and right. So if this is a standard form of a quadratic function, a times x minus h, then we are going to move the graph h units to the right. So my parent graph start from 0, 0. And for this function right here, it is x plus 3. So which means that this is the case where I'm going to move my graph h units to the left side. In this case, it is 3, so I'm going to move my graph 3 units to the left. So originally start from 0, 0, 1, 2, 3 units to the left. I'm going to start my graph from here. And if you remember, the pattern of this graph is going to go up 1 and then up 3 over 1, and then from here up 5 over 1. So this is the parent graph pattern if you don't have anything in front that is vertical stretch or shrink. For the next graph right here, it is x minus 3. It means that this is the type, and I'm going to move h units to the right side. So I'm gonna move the original graph 1, 2, 3 units to the right, and I'm going to go up 1 and then up 3. So this is going to be my graph that is moved 3 units to the right. Remember, it is a symmetrical graph. It means from the center of the point, if you go up, it's going to go 1 towards the left and right, and then up 3, left 2 unit, right 2 units. So whatever the distance from the center in this side is going to be the same distance on this side as well. For this graph where we have y equals a x minus h squared plus k, if it is plus k, then you're going to move k units up. If it is minus k, then you're going to move the graph k units down. In this case, I have a 3, it's plus, and I'm going to move up 3 units. So originally graph starts from here. It's going to move 1, 2, 3 up, and then you're going to follow the same pattern. 1 up, and then 3 up, and then 5 up. So there is going to be a graph that is 3 units up from 0, 0. Now for negative 3, which means this is negative k, go down 3 units. So you're going to go down 1, 2, 3, and 1 up, and 3 up, and 5 up. That's going to be your graph. For example number 1, describe the transformation for fx equals x squared, represented by gx equals x plus 4 square. So for the parent function, you start from 0, 0, and you follow the pattern that is 1 up over 1 and then up 3. So that's going to be the point. And then for this one, you're going to move the same type of a graph to the left 4 units. So it's going to be 4 units to the left from the original point. So you're going to move 1, 2, 3, 4. And going to follow the same pattern, that is up 1 and then up 3 and so on up 5. Example number 2, describe the transformation of fx equal x squared. So this is going to be your parent graph starting from 0, 0 and following the pattern that is up 1, up 3, up 5. So for the original pattern for parent graph is 1 comma 3 comma 5. You multiply this one with 3, and then you're going to get the pattern by 3, 9, and 15. So just remember that we multiply the 3 to the pattern and move up if we have a vertical stretch. But in this case is a vertical shrink, so it means that we are not going to move 3 up, 3, 9 up, and 15 up. We are going to move to the left or right 3 unit, or 9 unit, and 15 unit. So for example, you start from here. So this is your original graph. If it would be just 3, then you're going to move up 3, move up 9 over 1, move up 15. This is 1 over 3. We are going to use move Move 3 up 3. So move 3 up 3. So the next point is going to be this one. Okay, move 3 up 3, and that's going to be your vertical shrink graph. Remember, you can also use it like this. So if it is x that you choose 3, then you plug it in for x square. That is going to be 1 over 3 times 3 square, and that is going to be 1 over 3 times 9, so it's 3. So the shrink graph always is a comma a or 3 comma 3. So for example, if you have a y equals 1 over a x square, so whatever you choose for x, which is a, then you're going to get the same value for y. So it's a comma a, and if you choose 9, it's going to be 9 comma 9. So in this case, it's going to be 3 comma 3. Remember, if it's a pattern that you have in front of a number that is 3, 4, 5, 2, so on, that is greater than 1, then it's a vertical stretch. If it is 1 over 3, 1 over 2, 1 over or fraction of any time, then it's going to be a vertical shrink. In this case, is a vertical shrink. Example number 3, writing a transformed quadratic function. Let the graph of g would be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by translation 3 units down to the graph fx equals x squared. Write a rule for g and identify the vertex. Method number 1. Identify how the transformations affect the constant in the vertex form. Reflection in the x-axis means a negative sign in the front. Vertical stretch by 2 means that you're going to multiply the number 2 in the front. So it means that the a that is in the front is going to be negative 2, because negative for the reflection and 2 for vertical stretch. Now talk about the 3 units down means that the k is negative 3. So the k is going to be negative 3. In the whole problem, in this problem, we did not talk about left or right. It means the h is going to be 0. We're going to treat h is going to be 0. Vertex is normally we're going to write it as h comma k. So in this case, I can see that the h is 0, so it's going to be 0, and k is going to be negative 3, so it's going to be 0 comma negative 3. For method 2, first write the function h that represent the reflection and vertical stretch. So reflection and vertical stretch means that you're going to write down reflection negative sign, and vertical stretch means you're going to write 2 x squared. So this is going to be, remember, this is going to be my parent graph. So from the parent graph, you're going to write down the graph that is vertical stretch by 2 and reflected over the x-axis. So it's going to be negative 2x squared. Then you're going to write a function g that represents translation of h. So we are going to write down the g function, a new function that is translated function. So the translation is 3 units to down, so 3 units down. So this is going to be my function, which is the same function as the one that we previously made, negative 2x squared minus 3, negative 2x squared minus 3. You can either write 0 for h, or you can just avoid writing 0 because it doesn't really matter if we write 0 or not. For the vertex, you're going to see what is h. H is not there, so it's 0. And for the k is going to be negative 3. So please pause the video and try the try problems, and then watch it again. For number 7, let the graph of G be a vertical shrink by factor of 1 over 2, followed by a translation 2 units up of the graph fx equal x squared. Write a rule for G and identify the vertex. So the parent function for the graph is going to be fx equal x squared. So that's given, and it's a quadratic function. Vertical shrink by factor of 2, 1 over 2 means that you're going to multiply in the front of x squared as 1 over 2. And translation up 2 units means you're going to add 2 on the back of this function. So that's going to be plus k. Now to find the vertex, we are going to compare it with the standard form of vertex form. So the vertex form looks like x minus h squared plus k. So we're going to compare it with this. And we're going to rewrite this function as 1 over 2 x minus 0 squared plus 2. And if you compare now that the h is going to be 0 and then the k would be 2. So the vertex is going to be h comma k, that is going to be 0 comma 2. And the next question is you try. Write a rule for gx described by the transformation given by fx. Fx equals x plus 6 squared plus 9. Vertical shrink by factor of 1 over 3. So first step is to vertical shrink by factor of 1 over 3. Second step is translation of 1 unit down, followed by reflection in the x-axis. So our first step is going to be this one, and our next step is going to be a translation, and our last step is going to be a reflection. Let's do the first step, vertical shrink by factor of 1 over 3. So this is 1 over 3. We are going to make a change in fx. So we're going to multiply the entire function fx by 1 over 3. So that's going to be distributed inside. So 1 over 3 x plus 6 squared plus 1 over 3 times 9 over 1, and that is going to be 1 over 3 x plus 6 squared plus 3. So that is the gx, that is vertically shrunk by factor of 1 over 3. Now let's discuss the next step. So next step is a translation of 1 unit down. So we're going to translate it 1 unit down, so negative 1. And we are going to get the graph as 1 over 3 x plus 6 squared plus 2. Now the last step is going to be a reflection over the x-axis. It means you're going to multiply it by negative 1 in the front. So this is going to be negative outside, and you distribute it to inside. So negative and negative. So your final function is going to be negative 1 over 3 x plus 6 squared minus 2. And that is your translation in steps. So there are 3 steps. Vertical shrink 1 over 3, you multiply outside 1 over 3, distribute inside, and get the function, this one. For translation 1 unit down, you subtract 1, followed by reflection. So you're going to multiply this function by negative 1.